Would you like to learn COBOL programming? If your answer is yes, then this is the right place to begin your COBOL programming journey. Ladies and gentlemen, welcome back to our channel and the topic for today is of programming language. Moreover, if you find our COBOL programming 101 course engaging and wish to explore advanced Would you like to learn COBOL programming? If your answer is yes, then this is the right place to begin your COBOL programming journey. Ladies and gentlemen, welcome back to our channel and the topic for today's session is COBOL Programming 101. This course covers the fundamental of COBOL programming and it is Would you like to learn COBOL programming? If your answer is yes, then this is the right place to begin your COBOL programming journey. Ladies and gentlemen, welcome back to our channel and the topic for today's session is COBOL Programming 101. This course covers the fundamental of COBOL programming and it is designed for both beginners and experienced developers who are interested in expanding their skill set in COBOL programming. So before we deep dive into the overall structure of this course, I would request you to click on the subscribe button and become a part of our YouTube channel. By subscribing, you will gain access to wealth of valuable content, including our latest videos, tips, and comprehensive tutorial which covers a wide range of programming language. Moreover, if you find our COBOL Programming 101 course engaging and wish to explore advanced topics like COBOL Web Services interface, advanced file handling techniques, mock interviews, live demo classes, and a demo project to showcase the end-to-end process of designing and building a COBOL program. So for that, I invite you to explore our COBOL Complete Reference course on Udemy and Tutorial Point. I've already provided the link in the description. Alternatively, you can purchase this course directly from us and for that you have to drop an email to the email ID which is provided in the description. We will ensure that you get this course at a discounted price. Last but not the least, we greatly appreciate your support and engagement with our YouTube channel. If you find our content valuable and would like to further support us, then we would kindly ask you to consider contributing monetarily to our YouTube channel. We have provided the link in the description. Apart from that, you can also become a paid member of our YouTube channel. Your support will enable us to continue creating high quality videos, expanding our resources, and delivering even more valuable content to our community. Now let's deep dive into the overall structure of the course. This course is divided into different sections and each section focuses on a specific aspect of COBOL programming. So we start this course with Introduction to COBOL, followed by a brief history of COBOL and what is the future of COBOL. After that, we will deep dive into the overall structure of a COBOL program. That means what are the different divisions and what is the significance of each division. Thereafter, we'll talk about how to define variables, data type in your COBOL program. Additionally, the course covers various topics such as conditional statements, loop, string manipulation, redefine statement, rename statement, usage clause, along with other important COBOL statements. Apart from that, we have also provided an overview to COBOL Web Services interface, how to handle file in your COBOL program, how to handle database in your COBOL program. So let's get started with an introduction to COBOL. The term COBOL stands for Common Business Oriented Language. It is a high-level programming language and it is mainly used to develop business-oriented application. COBOL was designed specially for business applications, although you can use it for various programs and programming problem, but it is commonly used for business processes such as banking and financial services, retail sales tracking, payroll, and many other applications. The list is almost endless. So finally, COBOL is one of the oldest and most widely used programming language. It is not only used on IBM mainframe, but it is also heavily used on Windows and the cloud computing platform. Now let's talk about the features of COBOL. As you know that COBOL is predominantly used for business-oriented applications. And being an old programming language, it is still holding the ground due to its features. The following are the important features of COBOL. So the first one is standard language. COBOL is a standard programming language. This means that COBOL compiler are made available by different third-party vendors on almost all type of computers or computing platform. All these compiler manufacturers adhere to the norms set by ANSI. The second one is robust language. COBOL is a highly robust programming language. This means that there are a number of testing and debugging tools available for COBOL programs on almost all kinds of computing platform. These tools are developed by different third-party vendors based on the ANSI directives. Third one is English-like language. COBOL is an English-like language and it is very user-friendly. All instructions are coded using English words rather than the complex code. For instance, if you want to read a record from the file, then you will use the verb read. So COBOL is relatively easy to understand. Now the next one is structured programming capability. The term structured programming refers to a collection of techniques that help a programmer to develop structured program. And as you know that COBOL program is divided into different divisions and each division has its own significance. So for example, if you want to include your business logic, you generally use procedure division, and in procedure division, the business logic can be divided into paragraph or sections. And these paragraph or sections can be executed or re-executed as per your requirement. So in nutshell, you are writing a COBOL program by using a top-down approach and it is more readable and you can easily understand the business functionality or the business logic behind that particular program. COBOL is scalable, reliable with an excellent file and database handling capabilities. COBOL can very well handle huge volume of transactions and due to this fact, COBOL still handle more than 70% of world business transaction. COBOL is suitable for everything from simple batch reporting to complex banking transactions. COBOL is platform independent and it supports object-oriented programming. That means you can write your business logic in form of classes and then you can use those classes in your program. Last but not the least, for applications written in COBOL, the cloud offers another platform for rapid deployment and modernization. Because COBOL is both adaptive and highly portable, thus COBOL system can be quickly redeployed to a virtual or cloud platform with no change. Now let's deep dive into the history of COBOL. But before I discuss the important historical milestone of last 60 years, let me introduce you to a well-known personality, that is Grace Hopper. She was a pioneer in computer programming and played a crucial role in the development of COBOL. She is best known for her trailblazing contribution to computer programming, software development, the design and the implementation of programming language. She proposed the idea of writing programs in Word rather than symbols, but the idea was not supported by the community. Nevertheless, she continued her work on an English language compiler and in 1956 her team was running Flowmatic, the first programming language to use Word's command. In 1959, she took part in the Conference on Data System Language, the goal of which was to develop a common business language that could be used across industries and sector. And the final product was COBOL, that is Common Business Oriented Language. And lastly, I've also included a couple of important links in the description and you can very well use this link in case if you want to learn more about Grace Hopper. Now let's move on to our next section where we'll talk about the individual milestone of COBOL history. During the 1950s, the western part of the world experience a tremendous need for a high-level programming language that is suitable for business data processing. And to meet the demand, the US Department of Defense organized a conference on May 1958 to highlight and stress the importance of high-level business data processing language. The conference led to the formation of a team called CODASL, that is Conference on Data System Language. This team had representatives from civil and government organizations, academics, computer manufacturers, and other software enthusiasts to work towards the common goal. As a result, a new language called COBOL, that is Common Business Oriented Language, was developed in September 1959. This was released with some minor modification in April 1960. In May 1961, COBOL 61 was published with some minor revisions. It is this version which provides the foundation for later versions. In 1965, a revised version of COBOL was released with number of additional features. However, it was only in 1968 the COBOL was approved by ANSI, that is American National Standard Institute, as a standard language for commercial use. And this version of COBOL is known as COBOL 68. And from 1968 till 1985, there are multiple versions of COBOL that were released after including additional features. Multiple versions of COBOL compiler were released between 1986 and 2018 with features such as object-oriented programming, web supports, and many more. Now let's talk about the latest version of COBOL compiler which is available as of May 2022. So the latest version of IBM Enterprise COBOL for ZOS is 6.4 that support latest Z16 architecture. Enterprise COBOL 6.4 delivers modernization feature that improve developer productivity in addition to the performance, modularity, and maintainability of your code. It also reduces the operating cost. Now let's try to understand why COBOL still dominates the enterprise computing space. As you know that COBOL is extensively used for business-oriented application and it is one of the oldest programming language which is still in use. COBOL has a 60 years of proven track record for application production, maintenance and enhancement. Almost 70% of people use COBOL applications while traveling, withdrawing money from ATM, ordering burgers or pizzas, or visiting doctor, and many more. In reality, COBOL is the major programming language for business applications. Today, IT space is flooded with new programming language with tons of new feature, but still they cannot beat COBOL. COBOL is everywhere and most of the people use COBOL applications either directly or indirectly. More than 200 billion lines of COBOL code is still in use and it is growing at a constant pace. 9 out of 10 critical business applications are still relying on COBOL. Lastly, COBOL is a hidden asset and it's a backbone of business computing. Now let's talk about different sectors or industries that rely heavily on COBOL application. So the first one is financial sector. And in financial sector, almost 92 of the world top bank use mainframe to host their core banking application. Almost 26 billion transactions were processed daily by COBOL applications. The next sector is travel and tourism. So if you have booked a flight or check into a flight, then there is a good chance that your data or transaction is being handled by a COBOL application somewhere. Next one is healthcare sector. So whenever you visit doctor, the health record that he or she access about you are stored on mainframe. And probably there might be some COBOL application that is handling the data which was stored on mainframe. Similarly, your health insurance companies, they are also using mainframe application to settle claim or to provide policies. The last sector that rely heavily on COBOL applications are government agencies and retail sector. So majority of enterprise applications are designed in COBOL. In fact, majority of retail companies use mainframe to host their inventory management system. For example, Walmart or Tesco. Now let's talk about the future of COBOL as a programming language and try to answer whether you should learn COBOL along with other modern programming language. In recent years, there has been a lot of discussion about the future of COBOL. After all, it is an old language that has been around for almost 60 years, whereas the new language have a lot of new features that make them more suitable for PC-based application. Many IT professionals believes that COBOL is an outdated language because it is very old. But in reality, COBOL is likely to remain the important language for next couple of years, in fact decades. And there are two simple reasons for that. First one is COBOL source code is still growing with a constant pace. According to an estimate, there is almost 200 to 250 billion lines of code which is still active, and this code has been used in form of different legacy applications which is hosted on IBM mainframe or any other cloud computing platform as a part of modernization strategy. So the important point out here is that this piece of code which is already active is growing, and every year there are new set of code which is being introduced just to maintain these legacy applications. And second important point is that COBOL dominates the enterprise computing, and there are sectors that rely heavily on COBOL applications that is hosted on IBM mainframe. For example, you have banking and financial services, aviation industry, health sector, then you have retail sector. So these are a couple of sectors that rely heavily on legacy applications. And it is practically impossible or it is very difficult to replace all these legacy applications in next couple of years. In nutshell, most of the organizations are actually modernizing their legacy application so that they can leverage the functionality of legacy applications along with modern technology. Now coming back to our initial question, is it worth to learn COBOL? Well, the answer is absolutely yes, because you will definitely going to get chance to work on enterprise application where you are using legacy application, for example a banking application. So you might be using a core banking application which is hosted on IBM mainframe, and that application was designed in COBOL. On the other hand, you have a front-end screens that is being designed in modern programming language, for example, Java, .NET, right? So it is always worth to learn COBOL because COBOL will not going to die in next couple of years or probably in decade. It will always be there. Maybe the amount of code or the application might reduce, but it will not be eradicated completely. Now in the next section, we'll try to understand the basic difference between three important terms. First one is program, second one is operating system program, and third one is application program, because we would be using these terms interchangeably throughout this course. So first one is program. A program is a set of instructions that enable a computer to process data, and you can use various high-level languages to write these programs. You can use either .NET, Java, or maybe C, C++, or probably COBOL. That is purely up to you, right? And these programs are broadly divided into two different categories. First one is operating system programs, which actually control the overall operation of the computer. For example, Windows or maybe Linux or probably ZOS. So these are operating systems that are actually controlling your computer. And the second category is application programs, which actually perform the task required by the user. And an application program operates on an input data and convert it into a meaningful information. So let's say you want to generate a report that can list the number of failed transactions. So your application program would be using some input data, maybe transactional data that can showcase whether your transaction is successful or it had failed. And the business logic of your application program will translate or will read data from that input file and translate that data in form of a report that can outline the failed transactions. And lastly, the term used to describe all types of programs is called software. So I'm sure by now you're able to understand what is a program, what are the different categories of program, and how you can use the term software to refer to all these programs. Now let's talk about characters in COBOL. So let's get started. The most basic and indivisible unit of the COBOL language is the character. The basic character set includes the letter of the Latin alphabet, digits, and special character. In the COBOL language, individual characters are joined to form character strings and separators. Character strings and separators then are used to form the words, literal, phrases, clause, statement, and the sentences that form the language. The basic characters used in formatting character strings and separator in the source code is showcased in the following table. So if you look at the table, you can clearly understand what are the different characters that you can use to form strings and separator in your COBOL program. So you have A to Z as alphabets in both uppercase and lowercase. Thereafter you have digits, that is from 0 to 9. And thereafter you have operators, for example, plus sign, minus sign, asterisk, forward slash, equal sign, currency symbol, and couple of more special symbols or characters that can be used to perform strings or separator in your COBOL program. Now let's talk about the various components of a COBOL programming language. COBOL is one of the oldest programming language that is still in use. As a result, it has some unique features or requirement that might be cumbersome or hard to understand for programmers who actually work on other programming languages. One of the design goals of COBOL was to assist readability by making the language as English-like as possible. So for better understanding, I've divided the entire structure of COBOL into different components. And with the help of these components, you actually create your program or your program logic, right? So as of now, just remember that these are the different components, and in next couple of lectures, we're going to discuss each of these components in detail. So first component is character. Second one is reserved keywords. Then you have user defined words. Apart from that, you have variables, literals, and structures. After that, you have optional keywords, constants, and intrinsic functions. And with the help of these components, you can create your business logic of the COBOL program. Now let's talk about the reserved words in COBOL. So by definition, a reserved word is a character string with a predefined meaning in a COBOL source unit. They are basically divided into 6 different categories. First one is keywords, second one is optional word, third one is figurative constant, fourth one is special character words, fifth is special object identifiers, and the last one is special registers. But we will be focusing on first 3 important reserved words. So first one is keyword, second one is optional words, third one is figurative constants. Now let's talk about keywords. So keywords are reserved words that are required within a given clause, entry, or a statement. And within each format, such words appear in uppercase on the main path. Here are some examples of keyword. However, the list of reserved keyword is quite lengthy. So first one is add, which is generally used to add 2 or more variables as per your requirement. Thereafter you have delete, which is used to delete a record from a file. Thereafter you have search, which is used to search any specific value in an array or a table. Thereafter you have read and write, which is generally used to read data from the file or write a record to your flat file or maybe to your VSAM files. Similarly, you have call, which is actually used to call any subprogram from your main program. Now let me showcase how exactly you can use these keywords along with other optional parameter to write your business logic. In the following example, you have procedure division, which is actually used to specify your business logic. So in this case, we have a paragraph that is 0030-read-tremp, and it is actually reading data from a sequential file. And to read data, I've used the read statement. And in this case, if you notice, read is actually a keyword. In second statement, move is a keyword, and in second statement I'm assigning value y to end of file variable. And if you notice the last statement, I'm actually incrementing the counter by 1 whenever record is read successfully from the file. So in this case, add is a keyword, right? So at this point, only remember that these are the important keywords and they have a specific meaning in your COBOL program. And with the help of these keywords, you form syntax, and with the help of those syntax, you form your business logic. Now let's talk about the optional words in COBOL. So by definition, optional words are reserved words that can be included in the format of a clause, entry, or a statement in order to improve the readability of the code. They have no effect on the execution of the program. And a quick example of optional words are giving, round off, after, and there are many more, right? And if you look at the example, similarly we have used the procedure division to specify our business logic. And if you look at the statement, we are using add bonus to employee salary, giving EMP sal. So in this case, giving is actually an optional word. You can write this statement with the help of compute statement also. Similarly, if you look at the perform statement, so in this case, after is an optional keyword. So as of now, just remember that these are optional keywords which is used to improve the readability of the code, and they do not have any effect on the execution of the program. Now let's talk about constant and figurative constant in COBOL and try to understand what is the basic difference between these two different categories of constant. So let's talk about constant first. So a constant is a data item that has only one value throughout the execution of the program. So in the following example, I've defined two different variables that I'll be treating as a constant. So the first variable is department name and the second variable is mortgage interest rate. And if you notice, I've defined these two variables in a working storage section. The initial value of these fields is assigned with the help of value clause. And if you notice, for the department, I've assigned computers department, and for mortgage, I've assigned a value that is 1.0265. So throughout the program, I would be using these two variables, that is department name or mortgage interest rate, wherever I need the value of these variables in my business logic. Now let's move on to our next category, that is figurative constant. So by definition, figurative constants are the reserved words that name and refer to a specific constant values. So here's a list of figurative constants that you can use in your COBOL program while writing your business logic. So first one is 0, then you have zeros, which is actually a different variant of 0. Thereafter you have space, spaces, high value, low value, quotes, null, and all. There are a couple of more variants of these existing figurative constants. So in the following example, I've used three different variables that I've defined in the working storage section. And these different variables I'll be using as a temporary variables. I will not be using as a constant variable the way I've used in my previous example. So in this case, first one is department name, second one is mortgage interest rate, and third one is employee number. And the initial value of all these variables is assigned with the help of value clause and figurative constant. So for example, in case of department name, which is x of 30, that is alphanumeric. So what I've done is I've used a value clause along with spaces. So spaces is a figurative constant, and what will happen when you run this program? So this particular variable, that is department name, is filled with all spaces. So that means all 30 bytes will be having spaces as an initial value. And you can very well override the value of department name in your program during the execution. Similarly, you have mortgage interest rate variable. So in this case, I've used figurative constant as zeros. So that means that all the bytes, that is 5 bytes, will be filled with zeros. And for the last field, that is employee number, I've used figurative constant 0. So that means my employee number will have 0 as an initial value. And similarly, you can use other figurative constant to initialize these variables with a specific values. For example, high value, low value, quotes. So these are a couple of important figurative constants that you'll be using in your COBOL programs, and we're going to showcase how you can use these variables in our coming lectures. Lastly, to keep your code simple and consistent, it is always recommended that you use singular form of figurative constant, that is zero, space, quotes, high value and low value. Now let's talk about the rules and guidelines for writing a COBOL program. So before we get into the actual program coding rules, let's try to understand why do we have special coding rules for COBOL. So as you know that COBOL is one of the oldest and robust programming language that is still in use. And when COBOL was designed, that is during 1960s or 70s, during that time frame, you do not have modern programming tools to feed data into the computer. So in those days, punch cards were the only way to input data into the computers. Punch cards are the paper cards where hole may be punched either by the hand or by the machine. And these holes actually represent computer data and instructions. And lastly, these cards or stack of cards were fed into the card reader which is connected to a computer that eventually converts the sequence of holes into a digital information. So if you look at the right hand side of your screen, you notice a sample punch card with certain set of holes, and these holes actually represent information that can only be understood by a punch card reader. So punch card reader actually read this set of information with the help of these holes and translate that into a digital information. And last but not the least, one of the most widely used punch card machine was the IBM 029. Now let me summarize the entire process which was followed during 1960s or 70s to write a COBOL program. So let's say you want to write a COBOL program. So in that case, you will use a coding form or COBOL coding sheet, and on this sheet you'll write your COBOL program. After that you'll pass it your COBOL program to a punch card operator for transferring that into a punch card, and then submit it to a computer operator to load it into a computer using a punch card reader. Now let's talk about actual coding rules that you should follow when you're writing your COBOL program. And remember, these rules are derived from the coding sheet that was used to write COBOL program during 1960s, 70s. So in reality, the coding rules are absolutely same. The only difference is that during initial days of 1960s, 70s, you generally used to write program on a piece of paper, that is COBOL coding sheet, but now you are writing COBOL program with the help of integrated development environment such as RDZ or VS Code. Now let's talk about the actual coding rules that you should follow when you're writing your COBOL program. And these rules are actually based on the coding form or sheet that we have discussed in our previous slide. So each line in a COBOL program is considered to be of 80 columns. And these columns are further divided into 5 different fields, and each field has its own significance. So let's look at the significance of each field. So first 6 byte or column are reserved for sequence number, and sequence number are added to each line by the compiler during the compilation process, and they are not used anymore in modern days. You can leave them blank because they are actually used during the olden days when you have the punch card. Position number 7 or column number 7 is generally used for comments, continuation or form feeds. From position number 8 to 11 is termed as section A, and it is generally used for special entries such as division, sections, paragraph name, and some items of the data division. Then you have position number 12 to 72. It is termed as section B, and it is generally used for most of the COBOL entries including procedure division sentences. Then you have position number 73 up till 80, and this area is called as identification area. These positions originally were used to identify a program, but they are not used anymore today. Now let me showcase a sample COBOL program so that you can understand how exactly you can write your COBOL program which follows the coding rules that we have discussed so far. So here's a sample COBOL program, and if you notice the top column, it clearly outlines the 5 fields that we have discussed in our previous slide. So you have first 6 byte as sequence number, 7th position we generally use to specify comments or continuation. Area A, which is from 8 to 11, is used to specify your division, your paragraph name. Then you have area B, that is starting from position number 12 to 72, and in this section you include most of your COBOL entries and your program logic. After that you have position number 73 to 80, which is used for identification, and I've just left that blank. Now if you look at the right hand side of your screen, I've given 4 different divisions in which your COBOL program is actually divided. So first one is identification division, then you have environment division, then you have data division, and thereafter you have procedure division, where we use to specify the business logic. So in next couple of slides, we're going to look into each of the division and the orientation of COBOL program. So as of now, just remember that this is how you're going to write your COBOL program, and these are the positions that you have to keep in mind. Now let's talk about the data types in COBOL. So before we deep dive into the classification, let's talk about the term data type. So in layman term, a data type is a classification of data which tells the compiler how the programmer intend to use the data. Understanding the data types ensure the data is collected and stored in a preferred format. And most of the programming language support various types of data, including integer, character, string, floating, and boolean. We process this data in various ways, such as performing mathematical calculation or probably sorting them up in a specific format. This data comes in different form. For example, if you notice employee detail file, which is a sequential file, it is actually having different categories of data. So first column is an employee name, and it is actually a string of characters. After that you have employee age, which is actually an integer. Thereafter you have department name, which is again a string of characters. After that you have employee salary, which is again an integer value. After that you have employee monthly tax, which is a floating value, that is something with a fraction part, for example 10.01. So finally, a majority part of understanding how to design and code programs is centered in understanding the type of data that we want to manipulate and how to manipulate that data in our COBOL program. So in COBOL, there are only 3 types of data. First one is alphabetic, that is made up of upper and lowercase letters. Then you have numeric, which is actually made up of digits, that is 0 to 9. After that you have alphanumeric data, which is made up of letters and digits. There are 2 more additional categories of data type, which is edited numeric and edited alphanumeric. And these 2 categories is actually an extension of numeric and alphanumeric. So edited numeric is made up of digits and special characters. Apart from that, edited alphanumeric is made up of letters, digits, and special characters. And the important point that you should always remember is that edited numeric and edited alphanumeric are generally used for reporting or displaying data on your screens. So for better understanding, what I've done is I've extracted a couple of examples from the employee data file that we have seen in our previous slide. So in this case, the name of an employee, that is David Murphy, is classified as alphabetic. Similarly, the employee salary, that is 2000 euros, is classified as alphanumeric. Thereafter, you have age and monthly tax, so that is 30 or 10.20 is classified as numeric. In last 2 example, I've actually reformatted the data in a more readable format. So in first case, I've actually used the salary of an employee with a currency symbol and comma so that it could be more presentable in your report or probably on screen. And similarly, in my last example, that is edited alphanumeric, I've used a date and it is again reformatted with forward slash. So first of all, you have the day, and thereafter you have month, and thereafter you have year. So this is how you can use these different data types for categorizing data or printing data on the report or probably on the screen. Now let's talk about how to define a data name in COBOL. So let's get started. In COBOL, variables are called as data names. They're also referred as data item or elementary items, and I'll be using these terms interchangeably throughout the course. So by definition, a data name or identifier is the name used to identify the area of memory reserved for a variable. A variable is a name location in a memory in which a program can put data and from which it can retrieve data as per the requirement. Every variable that is used in the COBOL program must be defined in the data division. And the thumb rule to create a data name is that you can use numbers, letters, and hyphen with a maximum of 30 characters in each name. Now to define a variable, you need three important things. First one is a level number, that is to specify the hierarchy of individual item in a group variable or in the entire set of variables. After that, you need the variable name itself. Thereafter, you need a picture clause to define the type of data that you will be storing in that particular variable. After that, you need a value clause. This is used to specify the initial value or to assign the initial value to that particular variable. And we're going to deep dive into all these three important components in our next slide. Now let's talk about level numbers in COBOL. So by definition, the level numbers specify the hierarchy of data within a record, and it also identify special purpose data entries. A level number begins a data description entry and has a value taken from the set of integers between 1 and 49, or from one of the special level numbers, that is 66, 77, or 88. The following are the significance of the various level numbers that can be used to define a data item. So the first one is level 01, and it is used to define record description. Level number 2 to 49 are used to define fields within the record. Level number 77 is explicitly used for independent items. Apart from that, you can also use level 1 for independent items. Level 66 is used for rename clause, and level 88 is used for conditional names. Now let's look at a couple of examples so that you can understand how exactly you can use level numbers to define your records or individual items within the program. So we have a working storage section, and there are two group variables which is defined at level 1, that is with level number 01. The first one is ws-temporary-variables, and within that particular record description we have individual elements which is defined at level 5. So we have used level number 05 to define those variables. So first one is record length variable, which is defined with a picture clause, that is pic of 99, that is a numeric. Similarly, you have ws-emp-rec-in, and thereafter you have ws-error-message. And the second temporary variable, that's a group variable that is used to define conditional names, that is ws-end of file is a group variable, and at level 88 we have defined two variables. First one is end of file, it is basically a switch, and second one is not end of file, and they have a default value of n, y, and n, right? So by default the value is n, and based on my logic I'll keep on tweaking the value of these level 88 variables. Now let's talk about our next example. So in this case again we have a working storage section, and thereafter we have ws-emp-rec. So this is again a record description, and within that we have like couple of elementary items or variables. So first one is employee number, then we have employee name, and within employee name again we have few individual elements. So again ws-emp-name is a group variable. Within ws-emp-rec is the actual group element, right? Similarly, in this case, we have used ws-emp-first name, which is x of 12, and we have assigned a default value as space. So if you'll notice the last variable that is at level 77, which is used for defining an individual or independent items. So that is total hyphen rejected record count. And remember, level 77 is only used for independent item. You cannot use level 77 for group variables, right? So finally, before we move to our next section, so here's a quick tip. So first and foremost thing is level number 1 and 77 must always begin in area A. Level number 2 through 49 can begin in area A or B. Level number 66 and 88 can also begin in area A or B depending on how exactly you're defining these variables in your COBOL program. Now let's talk about picture clause in COBOL. The picture clause is used to specify the data type and the amount of storage required for a variable or a data item. It is denoted by picture, which is often abbreviated as pic. A picture clause is specified only for elementary data elements or items and consists of picture characters. Each picture character denotes storage to be reserved for a character of that particular type. The following are the general picture character and their meaning. So first data item is alphabetic, and the character that is used for defining alphabetic is A, and it can only store alphabetic, that is from A to Z. After that you have alphanumeric, and the character that is used to denote that is X, and it can store anything that is from A to Z or from 0 to 9 or any special character. After that you have numeric, and numeric is denoted by 9, and it is only used to store digits that is from 0 to 9. After that you have S, which is used to specify or denote sign. Thereafter you have V, which is used to specify or assume your decimal. It is used to specify your implicit decimal, and you're going to learn that like when we look at a couple of examples. After that you have numeric edited, and for that you have 9, which is again used for digits. Thereafter we have Z, and this is used in case if you want to suppress 0 on your reports, or maybe if you're printing checks for any customer. Thereafter you have comma, and it is used to insert comma within your amount or maybe within the string. Thereafter you have decimal point, and in case if you want to insert decimal point within some numbers, then you can use this. Apart from that you have minus sign, and it is used to display minus sign in front of the numerical data. Now let's talk about a couple of examples so that you can understand how exactly we can use picture clause followed by the specific characters. So in the following example, which is somewhat similar to what we have seen in our previous slide, so in this case we have a working storage section, and in that we have two variables. First one is a group variable and second one is an elementary variable, right? And if you notice that for a group variable, that is ws-temporary-variable, we did not specify any data type or any picture clause. So as I already mentioned, that picture clause is only used for elementary item. So in this case we have ws-rec-length, that means record length, and for that we have used picture clause, which is abbreviated as pic, followed by characters, and characters actually specify the data type. So in this case I want to store numerical data, so that means the length of the record, so I've used 9. And in this case I've specified 2 times 9, so that means the total length of this particular variable is 2. Similarly, if you notice the next variable, that is ws-emp-rec-in, in this case I've used 9, and in simple bracket I've used 06. So that means the size of this particular field is 6. So it can store any number between 0 to 6 times 9 in that particular variable. Now next is ws-error-message, and I've used x of 12, so that means it's alphanumeric and the length is 12. Similarly, if you look at next variable, that is ws-total-credit amount, and in this case I've used s, which is used to denote the sign, whether it's a positive, that means it's a credit. If it is negative, that means it's a debit. After that, I've used 9 followed by 8. So that means before decimal, you have 8 position, and V is used for implicit decimal. And after that, again, I've used 99. So that means after decimal, I have 2 places, right? Now the next variable that is employee department is defined as alphabetic, and the length of this field is 30 bytes. And the last one is employee salary, and I've actually used edited numeric and edited alphanumeric characters to define the data type of this particular field. And edited numeric and edited alphanumerics are generally used to display your data in a more meaningful format. That means your data is more presentable or readable. So let's say if this variable has 13,000 euros as balance, and if you want to display that on a report, so it will be printed as 13, comma, after that you'll have 3 zeros, after that you have a decimal point, and thereafter you have 00. Now let's talk about our next example, and again on the similar terms that we have discussed so far, we have defined 3 different variables. So first one is a group variable that includes couple of elementary items, and if you notice the second variable, that is employee first name, which is defined as x of 12. So for this particular variable, to assign an initial value, what we have done is we have used a value clause followed by figurative constant, that is spaces. Now let's talk about our last two variables, that is total rejected record count and total record count. And these are two temporary variables which will be acting as a counter to just showcase the total number of records that have been processed by the program. So the first one is total rejected record count, and it is defined at level 77. So that means it's an individual item, and the length of this particular variable is 9 of 5. And similarly, the last variable, that is total rejected count, again the length is 5, but in this case again we have used a value clause to assign an initial value of zeros. Now before we move to our next section, let me just highlight two important things. First one is regarding alphanumeric item. So all unused position to the right are set to spaces, and for numeric item, the unused spaces to the left are set to zeros. So these are the two important points that you should always keep in your mind when you're working with alphanumeric or numeric data items. Now let's talk about value clause in COBOL. So value clause is an optional clause, and it is used to assign initial value to the data item or variable. The initial value can be numeric literal, non-numeric literal, or a figurative constant. This initial value can be changed in the procedure division based on your requirement. So that means whatever value you have initially assigned to a temporary variable that is defined in working storage section, that can be changed when you're using that variable in your program logic, that is in procedure division. So the initial value of data item or a variable can be changed or modified under the following scenario. So first one is you are doing some calculation with the help of that temporary variable, or probably you're moving some value from other variable to that particular variable. These are the two possible scenarios where you change the initial value that you've assigned with the help of value clause. Now let's talk about a couple of examples so that you can understand how exactly you can use value clause when you're defining the variables. So again, we have a working storage section, and there are two different variables that we have defined here. The first one is a group variable, that is ws-temp-variables, and that include couple of elementary items. So the first one is ws-emp-rec-in, and this is 9 of 6, and we have assigned an initial value of 0 to it. After that, we have ws-error message, and it is x of 12, and we have assigned an initial value as spaces. And similarly, we have next variable, that is ws-total credit amount, and we have assigned a plus 0 as initial value, right? So this is how you can use value clause to assign initial value to the variables that you define. In our next example, we have group variable, that is ws-emp-rec, and there are elementary items which is defined under that particular group item. So if you notice, first name, last name, we have defined as x of 12 and x of 14, and we have assigned an initial value as space and spaces. After that, we have employed department variable, which is defined as alphabetic, and the length is 3. And we have assigned an initial value as med. So that means it's a medical department. So whenever you run your program, so this particular variable will going to have initial value as med, and you can very well change that as per your requirement in your COBOL program. Before I wrap up this session, I'm going to highlight a couple of important points. So first one is that in case if you're assigning any value and that is smaller than what you have defined. So in that case, if you have an alphanumeric field, then it would be filled with spaces on the right. And if you have a numeric field, then it will be filled with zeros on the left. And in case if you assign a value which is larger than what you have defined, then in that scenario, we will going to get an error message. That would be a compiler error message, or the truncation will going to happen. And the last one is related to numeric edited. And in general, you do not define these variables with value clause, because these items typically receives a value as a result of a move statement. Now let's talk about the overall structure of a COBOL program. So as you know that COBOL is a structured programming language, and it is widely used for business-oriented application. In fact, COBOL is far more clearly structured than any other programming languages. The COBOL program is divided into 4 logical divisions, and each division is further divided into different sections, paragraphs, sentences, and statement. Now let me precisely explain each division, and thereafter in our subsequent lectures we're going to talk about each division in detail and what are the different parameters that you generally use in each division. So the first one is identification division. It is used to identify the program to the operating system. This division is actually used for documentation purpose. Next one is environment division, and it is used to specify the file name and describe the specific computer equipments that will be used by the program. Third one is data division, and it is used to describe the input and output formats to be used by the program. It also defines any constant and work areas necessary for the processing of data. The last one is procedure division, and it contains the business logic. That means it contains instruction necessary to read input and process it and create output as per your requirement. Now, let me showcase a sample COBOL program so that you can understand how exactly the entire program is divided into different divisions. So in this program, you have 4 divisions, and these 4 divisions we have precisely discussed a couple of minutes back. So first one is identification division, then you have environment division, then third one is data division, and the last one is procedure division. So this is how you structure your COBOL program. If you want to further understand the different sections and subsections that you can include in each division, then do check out our course on Udemy or Tutorial Point. Now let's talk about group items in COBOL and how you can define them in your COBOL program. So by definition, a group item or group variable is one that consists of one or more elementary items. And to define a group variable, you need a level number, you need a data name, and a value clause. However, value clause is optional. The level number must be 1 through 49. Typically, you start with 1 and then you use multiple of 5. So for example, you use 1 to define a group variable, and the elementary items would be defined at level 5, and subsequently you can use 5, 10, 15 depending on the layout and your requirement. Level 1 item must begin in the area A. All other level numbers can begin either in area A or B. You cannot code a picture clause for a group item, and you have to code a picture clause for all the elementary items. A group item is always treated as an alphanumeric item, no matter how the elementary items in that group are defined. Now let's talk about an example so that you can understand how exactly you can define group variables in your COBOL program. So here's an example, and we have a working storage section where we have defined 2 variables, and the first variable is the only group variable, right? The second variable that we have defined, that is employee salary, is an elementary item. And if you notice, the first variable, that is ws hyphen temporary variable, it's actually a group variable where we have defined approximately 4 to 5 elementary items. In second example, we have a working storage section, and again we have defined three variables, and the first variable that we have defined, that is ws-emp-rec, is a group variable or a group item. And in this group variable we have again defined another group variable, that is ws-emp-name, which is actually a combination of initial, employee first name, and last name. Last but not the least, to make the structure of the data item easy to read and understand, you must align the level number as shown in the example. Now let's talk about the initialize statement in COBOL and how you can use that in your COBOL program. The initialize statement, which was introduced with COBOL 85, can be used to set the initial values of the field. It can also be used to reset the value of all subordinate items in a group. The easiest way to use this statement is to code it without the replacing clause and to refer to a group item. Then all the numeric fields in the group are set to 0 and all the alphabetic and alphanumeric fields are set to spaces. On the other hand, if you code the replacing clause, then you have to specify which type of field you want to change, and you can specify the characters that you want those fields to be initialized with. For elementary item, in case if you have used the initialize statement without a replacing clause, then the value of these elementary items will be set either to spaces or 0 depending on how it is defined. For group items, in case if you have specified the replacing clause, then only the data types that are specified in the clause are initialized. The other data types are ignored. The initialize clause always ignores fields that are defined as filler, fields that are redefined, and index data item. Now the last important point is that you should always use value clause to initialize your variable before you actually start your program. Right. So in case if you require initialization during the runtime, in that case only you should use initialize statement, or you want to reset or reinitialize the value of elementary item within an entire group. In that case only you should use initialize statement. One of the benefit and danger of using initialize statement is that you can initialize large record description and tables with a single statement, because it is pretty easy to do that. But let's say you don't need reinitialization of variable during the runtime and you do it carelessly with the help of initialize statement. So in that scenario, the performance of your program would be slow and you do not even notice that. Now let's talk about the syntax of initialize statement. So the syntax is pretty simple. You have initialize keyword followed by identifier 1. Thereafter you have replacing keyword. Thereafter you have additional options, that is alphabetic, alphanumeric, numeric, and these are used to specify the type of elementary items which is defined in your group variable. After that you have data by keyword followed by identifier 2 and literal 1. Now let's discuss an example so that you can understand how exactly you can use the initialize statement in your COBOL program. So in the following example, we have procedure division. After that, we have a brief description about the paragraph. And in paragraph A000-main-logic, I've used initialize statement twice to initialize a group variable, that is ws-cust-record. So this is actually a group variable which is defined in working storage section, and this group variable include different elementary items, for example customer name, customer address, customer salary, and couple of other details, right? In the first initialize statement, I've actually used initialize word followed by the actual group variable name, and in this case I did not use any replacing clause. So this is the simplest variant of an initialize statement, and when this statement is executed, it will automatically initialize or reset the value of elementary item based on the data type that you have used. The second statement is also doing the same thing, but this time I've explicitly specified what are the values it should use to initialize the alphanumeric and numeric data. So what I've done is I've used initialize keyword followed by the group variable name. After that, I've specified replacing alphanumeric data by spaces and numeric data by zeros. So in this case, all the elementary items which is defined as alphanumeric will be initialized with spaces, and all the elementary items which is defined as numeric will be initialized with 0. Now let's talk about level 88 condition and how you can use that in your COBOL program. A condition name is the name that refers to a condition. To define a condition, you use a level 88 in the data division. After defining the condition name, it can be used as the condition in an if, perform until, or evaluate statements. Condition names are frequently used with switches and flags. Apart from that, a condition name is always coded on the level 88 and has only a value clause associated with it. Since a condition name is not the name of the field, it will not contain a picture clause. Now let's talk about the syntax of level 88 conditions. So the syntax is pretty simple and it begins with level number 88 followed by a condition name, and thereafter you have a value clause to specify the value. Now let's talk about our example. So in the following example, we have defined a variable that is marital status with a length of 1 and the data type is alphanumeric. Now the three possible value of this particular variable is S, M and D. So S denote single, M denote married and D denote divorced. And all these three condition names are defined at level 88. And we're going to use that directly instead of using the marital status variable in our logic. So if you look at the procedure division, we have a paragraph that is A001 hyphen main hyphen logic. And if you look at the first condition, in order to print the divorce as a message, we have used the condition name divorce. So we have used if divorce, then display the message divorce end if. And in case if you don't want to use level 88 conditions, then you can directly use the variable that is if marital status equals to S, then display single. So this is how you can use level 88 conditions in your COBOL program. And finally, the condition name must be a unique name and its value must be a literal, which is consistent with the data type of the field preceding it. Now let's talk about the redefine statement and how exactly you can use that in your COBOL program. So by definition, the COBOL redefine statement is used to define the same field storage into two or more different ways. The definition and redefinition of the field refer to the same storage location or bytes. In this way, different data items can refer to the same memory location to reduce the memory space. And the program is easier to maintain as well. For instance, you can store a alphanumeric and a numeric data type at the same location using the redefines in COBOL. Also, you can redefine alphanumeric to numeric using this clause. COBOL redefine statement cannot have a value clause and it cannot be used at level 01 in the file section or in the report section. Now let's talk about the syntax of redefine clause or redefine statement. So the syntax is pretty simple. You have level number from 01 to 49. Thereafter you have data name 1, that is a new name of the redefined variable. After that you have redefines keyword followed by data name 2. And data name 2 is the source variable name that you want to redefine actually. So when you define a field, you use 01 for the top level group item. Then for the next level, you can use number 2 to 49. And in practice, most of the programmer use 05 for the second level and 10 for the third level and so on. Now let's talk about an example so that you can understand how exactly you can use redefine statement in your COBOL program. So in the following example, you have an employee record which is defined at level 01, and at 05 level you have employee record layout which is x of 30, and this 30 byte of storage is being redefined as first name and last name by a group variable that is employee name detail that actually redefines employee rec layout. And similarly, if you look at the next level, that is employee department name, actually redefine the employee rec layout once again into two different variables, that is employee department, that is x of 10, and employee address, that is X of 15. So if you notice, the previous redefinition was of complete 30 bytes, and in my next redefinition I've actually used 25 bytes. I've not used the entire 30 bytes. So this is how you can use redefine statement to redefine the same memory location which was used by different variables within that particular record layout. Now let's look at a couple of important rules that you should always keep in mind when you're using redefine statement in your COBOL program. The first and foremost rule is regarding redefine statement usage. So redefine clause must follow immediately after data name 2, and data name 1 cannot have value clause, right? So these are two important things and you should always keep in mind. The next one is regarding the level number. So the level number of data item 1 and data item 2 must be identical, and you should never use level 66 or level 88. The next one is regarding the data item size. So data name 1 size should not exceed data name 2 size. However, it can be less than data name 2. And the last one is, in case if you're using redefine clause in an array or table, then data name 2 item cannot have an occur clause. Now let's talk about the rename statement and how you can use that in your COBOL program. So by definition, the rename statement is used to define an alternative name or alias for data items or a group of data items. The rename clause also used to regroup several elementary data items into a record so that they can belong to the original as well as to the newly defined group. The rename clause is used with the special level number, that is level 66. And in general, the rename clause is not used very often because of the maintenance problem. In fact, it was used heavily during 1960s, 70s, and 80s. Now let's talk about the syntax of rename clause. So the syntax is pretty simple and straightforward. You have level 66, which is used to define your rename clause. After that, you have data name 1 followed by rename keyword. After that, you have data name 2. Then you have keyword through up till data name 3. Now, data name 2 through data name 3 is the original area of storage, and data name 1 is the new name that you can use to manipulate it. Now let's talk about an example and understand how you can use rename clause in your COBOL program. So in the following example, you have employee record, which is defined at level 1. Thereafter, you have employee record layout, which is a group variable, and it is defined at level 5. And it includes two variables. First one is employee first name, that is X of 15, and second one is employee last name, that is X of 10. And just below that, I've used level 66 with a variable name that is employee personal information, followed by a rename that is first name through last name. So I've actually renamed or regroup both first name and last name under employee personal information. So you can very well access these variables either by employee rec layout or by employee personal information as per your requirement. Now let's talk about a couple of important rules related to rename clause. The first one is all rename entries associated with one logical record must immediately follow that record's last data description entry. A level 66 entry cannot rename a level 1, level 77, level 88, or any other level 66 entries. Next one is no data item between data name 2 and data name 3 can contain an occur clause. And the last one is the abbreviation through and the actual word through are equivalent, and you can write any number of rename entries for a logical record. Now let's talk about the except statement and how you can use that in your COBOL program. The except statement is used to transfer data or system related information into the program during execution. And this data is transferred with the help of an identifier. And remember, there is no editing or error checking of the incoming data. The except statement is used heavily in applications which are designed to run on standalone PC. So when the except statement is executed, the computer waits for the user to type an entry on the keyboard and press the enter key. And when the user presses the enter key, the entry is stored in a variable identified on the except statement, and the cursor moves to the next line on the screen. On an IBM mainframe, the except statement gets its data from the sysint device. As a result, this device must be set to the terminal keyboard if you want your program to work interactively. Now let's talk about the syntax of except statement. So the syntax is pretty simple and straightforward. You have except keyword followed by an identifier. After that you have from keyword followed by a couple of additional options, and these options are used to read low volume data from the operator console or some other hardware devices or from the operating system itself. And remember, if the from option is omitted, then the data is read into the identifier with the left justification from the operator console. However, if the from option is included, then the data is read either from the specific hardware or from the operating system. Now let's talk about a couple of examples so that you can understand how you can use except statement in your COBOL program. In the following example, we have used except statement. After that, you have identifier 2, which could be your variable where you want to store the date. And after that, we have included from keyword, and then we have specified the date. And similarly, you can specify the format of the date that you want to get from the operating system. And similarly, there are other options as well, and you can use them as per your requirement. In our second example, we have actually get the today's date from the operating system or from the system, and we have used except. We have specified our variable name, that is a temporary variable, that is ws-tdy-date, and we have specified from date. So when you execute this statement, you'll have today's date, which will be returned by the operating system, and this date will be stored in your variable, that is ws-tdy-date, and you can use it as per your requirement. Now let's talk about another important statement, that is display statement, and how you can use that in your COBOL program. The display statement display one or more literal or variable values on the screen of a monitor or a terminal. After it displays these values, the cursor moves to the next line on the screen. On an IBM mainframe, the display statement sends its data to the sysout device, and the content are displayed on the output device in a specific order, that is from left to right, and in a sequence that you specified in your COBOL program. The display statement also play a crucial role in case if you're debugging a program. You can include display statements within your program logic to print the intermediate results. A display statement may be used to view any data item, even an entire record on the screen. Now let's talk about the syntax of display statement. So as you know, that syntax is again similar to what we have seen in except statement. So it is pretty simple and straightforward. You have display keyword, after that you have identifier or literal. And thereafter you have some additional option. For example, you can use upon with mnemonic name or environment name, and you have with no advance or advance option, right? Now let me just showcase an example. So here's our example. We have a procedure division, and after that we have a message that we have displayed with the help of display statement. And we have used display followed by hello world, and that is in quotes. And when you run this particular program, it will print hello world in the spool. So far we have discussed the basic concept of COBOL programming. Now it's time for us to write our first COBOL program to print hello world in spool. So let's get started. So here's our sample COBOL program, and it is one of the simplest program I've ever seen in my life, right? So you have two different division in that. First one is identification division, which is used to specify the documentation information and the program name. After that, I've included a brief description about the program. Thereafter, I have procedure division, which include my business logic, and there's a paragraph called A001-main, and in that particular paragraph, I've used display statement to print hello world in spool. So when you compile and run this program on IBM mainframe, the output would be hello world. Now it's time for us to discuss the logical control structure in COBOL and how you can use that in your COBOL program. So as you know that COBOL is one of the oldest, robust and structured programming language. And structured program generally use logical control structure to specify the order in which instructions are executed. These structures are same for all programming language. So in case if you learn how to apply them in COBOL, then you can very well apply them in any of the other modern programming language. The only difference would be the syntax, which is specific to a programming language that you are using to write your program. Apart from that, the terminology will remain absolutely same. So the four logical control structure are sequence, selection, iteration, and case structure. Now let's talk about each category one by one so that you can understand the terminology, and then we're going to look into how you can implement that in your COBOL program. So first one is sequence. So in sequence, the instructions are processed or executed in a specific order or sequence, that is step-by-step execution. For example, the following instruction will be executed from top to bottom. So in the following diagram, first of all, the move statement will be executed. Thereafter, you have add statement, which will be executed. And at last, you'll be executing the write statement. Now let me showcase an example so that you can understand how exactly the statements are executed in a sequence. So in this example, we have a procedure division, so which is being extracted from an actual program. And there is a paragraph called A001 hyphen calc hyphen month hyphen sal. So this is basically a calculation of monthly salary. And in this case, you have move statement, then you have compute statement and display statement. So these statements will be executed one by one from top to bottom. So first of all, we would be moving the monthly salary to a temporary variable, that is WSEMP sal. Thereafter, you have monthly area to WSEMP area. Thereafter, you have bonus, which will be moved to a temporary field, that is WSEMP bonus. And thereafter, we are just using a compute statement to sum up all these and store the result in total monthly salary field. And at last, we would be executing the display statement, which will display employee monthly salary in spool. Now let's move on to our next logical control structure, that is selection. So selection is a logical control construct that execute instruction depending on the condition. It is also called as if then else logical control structure. So in the following example, you have move statement that will be executed first, and after that, based on a condition, that is if then else statement, either add statement will be executed or write statement will be executed. Now let me showcase that with the help of an example. So if you look at the right hand side of your screen, again we have the same procedure division which is extracted from actual COBOL program, and you have a paragraph that is A001 hyphen calc hyphen month hyphen salary. So in this paragraph you have a couple of move statement, and there is one move statement that is initializing employee bonus with zeros. That is again a figurative constant that I've used in this case. After that, based on employee grade, I am moving the employee bonus to temporary employee bonus variable, right? So if my grade is 3, in that case only I would be moving this EMP bonus value to temporary bonus variable. And finally, at the end, I would be doing a compute statement. I'm using a compute statement to calculate the total salary amount. And again, I'm using a display statement that is just displaying your total salary amount in spool. Now let's talk about our next logical control structure, that is iteration. So iteration is a logical control structure used for specifying the repeated execution of a series of statement or steps. So in the following diagram, first of all, the move statement will be executed, and after that, the read statement will be executed continuously in a loop till the time the condition is satisfied. Now let me showcase the same with the help of an example. So if you notice the right hand side of your screen, there is an example that is using perform statement. And this is an inline perform statement. And within this perform statement, you have read statement that will read data from the file. And this read statement will keep on executing until the condition is satisfied. And that means until you do not have any more record in the file. Now let's talk about our last logical control structure, that is case structure. So the case structure is a special logical control structure, and it is used when there are multiple paths to be followed depending on the content of a field or a variable. So in the following diagram, the first move statement will be executed because there is no specific condition which is specified on it. And after that, you have a condition, and based on that condition, these three statements will be executed. And remember, all three will not be executed, only one of the statement will be executed. But that execution will depend on the content or the value of a given field. And how you can implement that in COBOL? So for that, you generally use evaluate statement. So in the following example, if you notice, we have a paragraph called A001-calc-month-salary. So in this case, we have used the evaluate statement that says evaluate true, followed by a couple of when statements. And these when statements are used to specify the possible values for this particular field. And based on these particular values, the statements will be executed. And whenever one condition is satisfied, the remaining set of conditions will not be validated. It is simply bypassed, right? So evaluate and if then else statement is somewhat similar, but you have more flexibility and more readability in evaluate statement, and we're going to discuss that in our next couple of lectures. And so as of now, just remember that for case structure, you generally use evaluate statement. Now, in case if you want to further understand what are the different formats of each control statement and how you can use them in your COBOL program, then do check out our course on Udemy and Tutorial Point, because we have live demo classes that showcase how you can use them in your COBOL program. Now let's try to understand how to perform string manipulation in your COBOL program. So as you know that string manipulation is an important aspect of any programming language. And in most of the cases, you have inbuilt functions that can be used to perform various operations to fulfill your business requirement. Now let's try to understand what are the general operation you use to perform with a string. So let's say you have an input file which is holding an employee data, and it includes various details related to an employee. For example, you have employee name, age, department name, and the salary. So let's say you want to split the name of an employee into first name and last name. So in that case, you can use split function. Similarly, if you want to merge first name and last name and you want to include comma after first name, then probably you can use merge function or concatenation. And in case if you want to extract any specific information, so let's say in this case I want to extract the department name, then I can use extract function. And lastly, if you want to count specific characters in a string, then probably you can use the count function. So these are the general operation we use to perform in our day-to-day life. And all programming language comes with built-in functions, and you can very well use that to perform various operations as per your requirement. Now let's talk about the various functions or clauses which is available in COBOL, and with the help of these functions you can perform these operations that we have discussed so far. So the first one is string clause, and it is used to concatenate two or more sending fields into a receiving field. Then we have unstring clause, which is generally used to split or unstring a field into multiple fields which is specified in the into clause. Then we have inspect statement, which is used to count or replace characters within a field or a string. And lastly, you have reference modification that can be used to extract or overwrite data at a specific location within a field. Now, in case if you want to deep dive and want to understand how exactly these statements can be used in your COBOL program, what is the syntax and what are the different parameters that can be used within these individual statements, and what are the different formats. Now, in that case, I would highly recommend that you should go and check out our COBOL course on Udemy and Tutorial Point. We have given the link in the description, because in these courses we have actually created individual lecture on all these statements, and we have also showcased how you can use them in your COBOL program with the help of a demo class. On top of that, you can also download these COBOL programs, JCL and the data file so that you can practice on your own. Now let's talk about COBOL tables or array and how exactly you can use them in your COBOL program. So let's get started. In the business world, Microsoft Excel is one of the most widely used applications. You can store data, perform different calculations, and generate report instantly. But with COBOL on the mainframe, built-in features can help you create table and generate reports. Although they are not as sophisticated or seamless as Excel, but they are still powerful and can be used to run mission-critical applications on a global basis. They have been one of the most important functions of COBOL and the mainframe computer. In fact, the applications of COBOL table are seemingly endless. You can set up a table to compute taxes, determine the premium for insurance, or come up with a forecast of sale. Keep in mind that a COBOL table is the language version of an array. In a typical programming language, an array stores a string of data and each data item is referenced with an index number. But COBOL has its own approach. The index is instead called as subscript and it starts with 1 instead of 0 in other programming language. So by definition, an array in COBOL or table in COBOL is a linear data structure that is used to store, access, and process data easily and efficiently. It is a collection of homogeneous data that can be referred by a single name. The data item contained in COBOL table are called its element and can be used in an arithmetic and logical operations. The elements of a table are stored contiguously in the memory and it can be either elementary items or group items, and further a table can be either of fixed length or a variable length. In COBOL, an array or a table can have dimensions up to 7. But in general, programmers use 1D, 2D or 3D arrays or table. Now let's talk about our next topic, which is occur clause in COBOL, and it is used to define table in your COBOL programs. So by definition, the occur clause is used to define the table. It actually indicates the repeated occurrence of field with the same format. Apart from that, a table is defined in the working storage section of the COBOL program, and the business logic to store and access data from the table is specified in the procedure division. Now let's try to understand the entire concept with the help of an example. Now let's say you want to record the temperature of an individual place or a city, and this temperature will be recorded after every hour. So in total, you will have 24 different entries for the entire day. So in case if you want to implement the logic without using table, then you have to define 24 different variables, and each variable is corresponding to an individual time or an hour of that particular day. And by using the traditional method, coding the input record with 24 different entries for individual hour would be a cumbersome process, and it would be difficult to store and access data from these variables in your program logic. So instead of using these variables, you can use COBOL table. Now let me showcase how you can define a table to store temperature for 24 hours. So in the following example, we have a working storage section, and in that working storage section, we have defined a table with a name that is ws-hr-temperature-record, and it is defined at level 01. After that, at level 5, we have defined the field name that is ws-hr-temperature, followed by an occur clause. After that, I've specified the number of times I want to repeat this particular field. So I've specified 24 because I want to store the temperature for 24 hours. After that, I've used the picture clause to specify the data type. And in this case, I've used S9 of 3. And we have used S in the picture clause for cities in which the temperature might fall below 0 degree. So finally, we have used one occur clause to define 24 individual identical fields to store the temperature for the entire day. So before I showcase a couple of more examples of how to define 2D and 3D array or table, I would like to mention that occur clause can only be used at level number 2 to 49. It cannot be used at level number 1 because it is used to define fields, not the records. Now let's talk about our next example. And in this example, I'm actually using a value clause while defining a table. So the name of the table is ws-year-month, and I've used level 01 to define that. Thereafter, I've used a value clause, and within quotes, I've specified the abbreviation for individual month. For example, if it is January, then I've used Jan. If it is February, then I've used Feb. Now at next level, I've defined the field that is ws-month, and that occurs 12 times. And the length of individual field is x of 3. And when this piece of code is executed in a COBOL program, it will create a pre-initialized table. And when I say pre-initialized table, that means that a variable ws-month first occurrence will going to have January, second occurrence will going to have February, third occurrence will going to have March, and the last occurrence will going to have December. Now let's look at how to create a two-dimensional array. So in the following example, we have a working storage section, and there we have defined a table that is ws-temperature-record. And within that, we have actually defined a next variable at level 5, that is ws-days, that occurs 7 times. And then within those days, we are actually recording temperature for 24 hours. So we have defined ws-hours at next level, that is level 10, and that will occur 24 times. And the actual variable which will going to hold the temperature is ws-temp, and it is defined as pick s9 of 3. So this is how you can store 24-hour temperature for 7 days. Now let me showcase my third example where we are defining a three-dimensional array or a table. So we have a working storage section where we have defined the table definition. So the table name is specified at level 1, that is ws-temperature-rec, and after that at level 5 I've defined the month, that is ws-month, and that occurs 12 times. So we would be storing the temperature for entire year, and within that month, in order to store the temperature for individual day, I've defined the next variable at level 10, that is ws-days, occurs 31 times. So every month we're going to have 31 days. Next, at level 15, I've defined the hour, and that occur 24 times. And after that, I've actually defined the variable that will going to hold the temperature. So in short, you have 12 months. Within those 12 months, each month will going to have 31 days, and each day will going to have 24 different slots where you're going to store the temperature for that particular day. Now let's talk about our last example where we'll try to understand how you can use group data items within a table definition. So in this case, we have a working storage section. There we have a table name that is ws-book, which is defined at level 1. And at level 5, we have actually defined another variable that says ws-book-detail, and it occurs 100 times. And this particular record will store the data of an author and a title. An author is a group data item that will include first name, middle name, and the last name. So this is how you can define group items in table as per the business requirement or as per your program logic. So far, if you like this course and if you're interested in expanding your knowledge of tables and their implementation in COBOL program, then I would highly recommend that you should explore the advanced edition of this course. In that course, we have actually showcased how you can load data into a table, how you can access data from the table, how you can use the set statement, and what are the different functions that you can perform on a table with the help of a demo class. We have also given the link in the description, and the advanced version is available on Udemy and Tutorial Point. Now let's talk about COBOL move statement. So by definition, the move statement moves data from a literal or a sending field to one or more receiving fields. But the original data is retained in the sending field. It is necessary that the data move is converted to the usage of a receiving field. Apart from that, the source and destination identifiers can be a group or an elementary data items. Now, when we talk about data movement, there are three different categories of data movement. First one is alphabetic, second one is alphanumeric, and third one is numeric. And remember, when a field is moved to an alphanumeric edited or numeric edited fields, then the field is called edited. That means that the data is converted to a more readable form. But when a field is moved from a numeric edited field to a numeric field, the field is de-edited. That means the field data is again converted into a compact form as per the usage of the field. And lastly, if the receiving field is larger than the sending field, the receiving field is filled out with the trailing spaces in alphanumeric move and leading zeros in a numeric move. And if the receiving field is smaller than the sending fields, the data that move may be truncated. Now let's talk about the syntax. So the syntax of move statement begin with the move keyword. After that you have identifier1 or literal1, which is actually a sending field. Thereafter you have to keyword followed by an identifier2, which is actually a receiving field. Now let's talk about an example. So in the following example we have procedure division and we have used couple of move statement to move data from one field to other field. And we have also used a move statement to assign numeric values to a variable. So in this case, in first example, we have employee hyphen number, which is being moved to ws hyphen emp hyphen number. Similarly, we have second statement, which is moving employee first name to ws hyphen emp first name. So far, if you have any question, then do write down in the comment section. We're going to respond back as soon as possible. Now let's talk about the usage clause. Computers store their data in the form of binary digits. Apart from the positive integers, all the other data stored in the computer memory use some sort of formatting convention. For instance, text data is stored using an encoding sequence like ASCII or EBCDIC. Now you might be thinking that what is an encoding system? So an encoding system is simply a convention that specify that a particular set of bits represent a particular character. For instance, the following figure shows the bit configuration used to represent an uppercase A in the ASCII and EBCDIC encoding sequence. From numerical data perspective, COBOL as a programming language give you a lot of control over how numeric data is held in a memory. In COBOL, numeric data can be held as a text digit, that is ASCII digit, or it could be in binary numbers or as a decimal numbers using binary coded decimal, that is BCD. You can use the usage clause to specify how a data item is to be stored in the computer's memory. Every data item declared in a COBOL program has a usage clause even if you do not specify the usage clause explicitly. The default usage clause is usage is display. Apart from that, usage clause also play a crucial role in improving the efficiency of a COBOL program. Now you might be thinking that how come a usage clause can improve the efficiency of a program? Now with the help of simple example, I will explain that usage clause plays a crucial role in the overall performance of a COBOL program. Now in the following example, we have three different variables, that is A, B and C, and they are defined as numeric, and we have not used any usage clause for these variables. So the default usage clause, that is usage is display, will be applied. So the initial value of all these variables is 4, 1 and 0. So we're going to add A and B and store the result in variable C. So as I already mentioned that none of the data item have an explicit usage clause, so they are default to usages display. This means that the value of variable A, B and C are stored as ASCII digits. Now this in turn means that the digit 4 in A is encoded as 00110100 and the digit 1 in B is encoded as 00110001. When these binary numbers are added together, the result would be 011000101, which is the ASCII code for the lowercase letter e, which is absolutely wrong. So in case if you perform any calculation on two numbers which is stored as ASCII, then you'll end up getting the incorrect result. So due to this fact, when the calculations are done with the numeric data items using usage is display, the computer has to convert the numeric value to their binary equivalent before the calculation can be done. When the results are computed, the computer has to reconvert it to the ASCII digits. So this conversion of data from ASCII to binary and from binary to ASCII slow down the computation process. And due to this fact, the data that is heavily involved in computation is often declared as usage is computational, that is optimized for calculation. So finally, the default representation, that is usages display used by COBOL for numeric data items, can negatively impact the speed of computation. Apart from that, there are a couple of additional points that you should always remember when you're using the usage clause in your COBOL program. And the first one is that the usage clause may be used with any data description entry except those that are defined at level 66 or 88. When the usage clause is declared for a group item, the usage specified is applied to every item in the group. The group itself is still treated as an alphanumeric data item. The usage clause used for an elementary item cannot override the usage clause for the group to which it is subordinate. The next one is usage is computational, or comp or binary are synonym of each other. So you can use any three of the keyword as per your requirement. The usages index is used to provide an optimized table subscript, and any item that is declared with usage is index can appear in search or set statement, or maybe you can use with using phrase in your perform statements. And lastly, the picture clause used for comp and peg decimal item must be numeric, and the picture string can contain only the symbols 9, S, V, or P. Now let's talk about the syntax of usage clause. So the syntax is pretty simple. We have usage is followed by the different options. For example, we have binary, computational, comp, index, pack decimal, or display. And in case if you do not specify anything, then the default is usage is display. Now let's talk about our example. So in the following example, we have working storage section where we have defined a couple of variables. So first one is ws-emp-name, and this is defined as pick x of 20, and the initial value is spaces. So we have not used any usage clause for this. So the default is usage is display. The next one is ws-emp-sal. So in this case, we have actually used pick s9 of 5 comp 3, and the initial value is 0. And s in this particular variable definition denotes the sign, and it is used to retain the sign whether it is negative or positive. Of course, this is a salary, so it is always be positive. The next one is ws-emp-text, and it is defined as 9 of 2 comp, initial value as 0. After that, we have ws-emp-name, which is defined as x of 30, and right now we have defined as usages display. So this is how you can use the usage clause to improve the overall efficiency of the COBOL program. So far, if you have any question, then do mention in the comment section. Otherwise, let's move on to our next topic, that is arithmetic operations or calculations in COBOL. So by definition, an operation performed with number is termed as arithmetic operation or mathematical calculation. An arithmetic expression is a combination of an arithmetic operator and a variable or a data item. The following are the 5 binary arithmetic operators and the 2 unary operators. Both binary and unary operators can be used in an arithmetic expression. Now let's talk about all these operators one by one. So first binary operator is plus, which is used for addition. After that you have minus, which is used for subtraction. After that you have asterisk, which is used for multiplication. Thereafter you have forward slash, which is used for division. After that you have two asterisk, which is used for exponentiation. And the first unary operator is plus, which means multiplication by plus 1. And the next one is minus, which means multiplication by minus 1. So far, if you like this course and if you're interested in expanding your knowledge of arithmetic operations and their implementations in COBOL program, then I would highly recommend that you should explore our advanced edition of this course on Udemy and Tutorial Point. Now let's talk about our next topic, that is COBOL call statement. Now let's try to understand what is a COBOL subprogram or subroutine and a COBOL main program. If a COBOL program is the first program in a run unit, that COBOL program is termed as main program. And all the other programs within that run unit is termed as subprogram. However, there is no specific code through which you can identify whether this is a subprogram or a main program. It purely depends on the system designer and the programmer who is actually transforming all the business requirement into a subprogram or a main program as per the project requirement. And always remember that a main program can call any subprogram. In fact, subprogram itself can call other subprograms. There is one more terminology which is used for main program and subprogram, that is called and calling program. So the program that calls other program is referred to as calling program, and the program it calls is referred to as called program. So here is a legacy application which is actually using a main program, a copybook, and a subprogram. So main program is the first program in the run unit. So in this case, there's a program called DSP01 which is actually acting as a main program. So what I've done is I've included the core business functionality in this program, and it is using call statement to call the subprogram. And if you look at the right hand side of your screen, you'll see the subprogram that is tax01, and it is actually calculating tax on employee salary. You also have a copybook. So copybooks are generally used to include file structure or probably any other common piece of logic that can be included in your program. And you can include copybooks in your program with the help of copy statement, and I've created a separate video on that. I would request you all to watch that video so that you can understand how and when you should use copy statement in your COBOL program. Now let's look at simple example so that you can understand how a business functionality is split between a main program and a subprogram. So in this example, you have a main program which is calculating the salary of an employee for a specific month. The main program calls two subprogram to calculate the salary and tax for a specific month. In first call, the main program pass EMP ID and grade as an input to the subprogram. The subprogram calculate employee salary and return the value to the main program. Similarly, in second call, the main program pass employee ID, salary, and tax slab as an input to the second subprogram. The second subprogram calculate the tax and return value to the main program. Now let's focus on COBOL call statement syntax, because main program can only call subprogram with the help of call statement. So the syntax of call statement is pretty simple and straightforward. It begins with the keyword call followed by the program name, and if you want to pass any value from the calling program to the called program, then you have to use the keyword using followed by a variable name. Now let's go through the example of a COBOL call statement. In first example, the COBOL program which is calling subprogram is running on IBM mainframe, and in this case you need to specify the call followed by a program name. So in this case it is EMP tax01, and I'm passing two values to the subprogram. First one is EMP sal and the second one is EMP tax. Similarly, if you are just using call statement on microfocus COBOL, then syntax is same, but you need to pass the actual location of the subprogram along with variable names. Now let's go through the complex variant of COBOL call statement, and in this variant you have more control over the data which is passed to the COBOL subprogram. And with the help of these three parameters, that is call by reference, call by content, and call by value, you can control the way subprogram is accessing or updating the data that you are passing from the main program. And if you do not specify any of the three parameters, then system will assume by reference as default value. The next set of parameter, that is on exception, not on exception, and returning. So these three parameters are generally used to execute a set of statement that you want to execute in case if there is any specific condition happens. For example, you're calling a program and call fails due to any reason. So the set of statement you specify under on exception will be executed. Now let's discuss these three parameters one by one. So first one is call by reference. So when the data is passed by reference, the address of the data item is supplied to the called subprogram. So any change made to the data item in the subprogram are also made to the data item in the main program. because both items refer to the same memory location. And if you look at the flow diagram, program A, which is a main program, is calling subprogram, that is program B, and it is passing the address of the data item. Therefore, program A and program B are accessing same memory location. But when the data is passed by content, a copy of the data item is created and the address of the copy is supplied to the subprogram, and any change made to the data item in the subprogram will only affect the copy of the data item. So if you look at the flow diagram, program A, which is a main program, is calling subprogram, that is program B, and it's passing the data. So what it does, it just create a copy of the variable or the data item and then pass the address of that particular data item to subprogram B. And subprogram, if it makes any changes to those particular variables or the data item that it has received from program A, then those changes will only reflect in subprogram B. It will not be reflected in program A. And the reason behind that is that both programs are actually accessing different memory location. The last parameter is call by value, and when you use call by value, the calling program passes the value of data item instead of the reference to the sending data item. The call program can change the parameter, but the change do not have any effect on the calling program arguments because the subprogram only has access to a copy of data. Now let's focus on the various methods of transferring control from one program to other program. So in general, the call statements are divided into two categories. First one is static call and second one is dynamic call. Now let's try to understand the difference between static call and dynamic call. In the static call, the COBOL program and all the called programs are part of the same load module. In dynamic calls, the COBOL subprogram is not link edited with the main program. Instead, it is link edited into a separate load module, and it is loaded at the runtime only when it is required. But in static calls, the load module is already present in main storage, and the branch to the subprogram is performed. And whenever you have subsequent execution of call statements, whether it is static call or dynamic call, the call program will always be in the last use state. But if you specify the initial attribute in the called program, then the program will always be in the initial stage each time the called program is called within a run unit. And the last point is the compiler option which is used to compile the program is non-dynam and no DLL for static calls, and for dynamic calls it would be dynam and no DLL. Now let's focus on an example so that you can understand how exactly control is flowing from main program to subprogram and how exactly control return back to the main program. So if you look at your screen, you have two programs. First program is a calling program, or it's a main program, and the second one is a called program or a subprogram. So in main program you have a call statement that is calling your subprogram, that is emp tax01. So in this example, while calling the subprogram, I'm not passing any data. So it's a simple call, and when the call statement is executed in the main program, the control will be transferred to the subprogram, and the logic which is included in the subprogram is executed, and finally control will return back to the main program and it will start executing logic after the call statement. The important thing that you need to remember is that you should never use stop run in subprograms because it will terminate the call. So that is why you always use exit program or maybe go back statement. Now let's look at second example where we would be sending data from main program to subprogram. So in this example, again we have two programs. First one is a main program and second one is a subprogram. And if you look at the main program, we have working storage section where we have defined two variables. First one is salary and second one is text. So we would be sending salary to the subprogram. The subprogram calculate the text and return the value to the main program. And if you look at the variables which is defined in working storage section and the linkage section of the subprogram, you'll see the sequence. The sequence of these variables is exactly same, and in fact the length is also same. And if you notice, the sequence of variables which is used in the call statement of main program is exactly same with the sequence of variables which is used in your subprogram. So in call statement you have first you have employee salary, then you have employee text, and in this subprogram you have WS salary and you have WS text. You should always maintain the same sequence and the same length of the fields. However, you can change the name of the variables as and when you're required. The way I've done in main program, I'm using emp-sal, and in my subprogram, I'm using ws-sal. Now let's go through a couple of important points related to COBOL call statement. And the first point is that a subprogram must be compiled and it should be ready for execution before you actually compile your main program. And you should always use exit program or go back statement in your subprogram. You should never use stop run. Static call is faster than dynamic calls because the main program and subprogram are part of the same module. If space is a concern, then you can think of dynamic calls. Otherwise, you should go for static calls. And last point, the sequence of fields in the call statement and the linkage section of a called program should be same. Now let's talk about how to handle files and database in your COBOL program. A typical modern application may not use files frequently, but it might use database to store and retrieve data. It makes sense since many applications do not typically handle data processing. This goes back to the early days when businesses want to find a way to replace the tedious approaches of using ledgers or any other business-oriented activity that requires human intervention. And during that time frame, the mainframe and COBOL were seen as a way to automate the back office. In fact, COBOL is an excellent language for handling data files because it is able to handle them clearly, accurately, and quickly. The majority of enterprise applications rely on files and relational databases such as DB2. In general, there are different set of files which is used by enterprise application, and this category include index file, sequential file, or relative files. Apart from that, you have generation data groups which is generally used for backups. Now let me precisely give an overview of a file and a database. So first of all, a file is made up of individual records. A record is a collection of individual fields or data items, and the format of records in the file are defined in your COBOL program. On the other hand, a relational database management system or RDBMS is a common type of database that store data in tables. So it can be used in relation to other stored data sets. Now let's talk about various operations that you perform on data which is stored either in file or in a database. So the first operation is read, and in this case you actually access data from the file or from the database. The next one is write, and in this case you actually write data either to a file or to a database. The next one is update operation, and in this case you access data from the storage medium, make some changes, and then again store that data back to the storage medium, and the storage medium can be a file or a database. And the last operation is delete, and in this case you actually delete or remove the data from a file or from the database. And remember, if you want to perform these operations on a data which is stored in a file, then you have to use native COBOL commands such as read, write, rewrite, or delete. And if you want to perform the same operation with the data that is stored in a DB2 table or a database, then you have to use the SQL statements such as select, insert, update, or delete. Now let's move on to our next section, and in this section I will demonstrate how COBOL program interact with files and databases. And in total we're going to discuss 4 different examples. First one is a simple COBOL program that is dealing with a file. Then we have a COBOL DB2 program which is dealing with a DB2 database. Thereafter we have a COBOL CICS program which is again dealing with a file, and last one is a COBOL IMS program which is dealing with an IMS database. And after going through all these 4 examples, you can clearly understand what is the structure of the program and how exactly these programs are designed and used within these different ecosystems. So let's get started now. So in the following example, we have a sample COBOL program that is dealing with a sequential file. And if you notice, there are 4 different division. First one is identification division, then we have environment division, thereafter we have data division, and the last one is a procedure division. So this program is actually reading data from the file. And if you look at the structure of the program, you'll clearly notice that the file details, that means the file that you want to read in your program, is specified in file control section, which is a part of environment division. And in file control section, you specify the name of the file that you'll be using within your COBOL program. Apart from that, you specify the corresponding DD name that will be used in the JCL. After that, you have data division where you have file section. There you'd specify the actual layout of the file. That includes the name of the field and the length of those corresponding fields. Then you have working storage section, which is generally used to specify the variables that you will be using in your COBOL program. After that, we have procedure division, which is used to specify the business logic. And if you notice the procedure division, we have a paragraph that is A000-core-processing. And the file that we have specified in our file control section and the layout that we have specified in data division is processed in this particular section or division. And what we have done is to open a file, we have used the open statement, right? After that, to read a data from the file, we have used a read statement. And finally, we have used the close statement to close the file that we have opened before issuing a read command. And the last statement is stop run, which will terminate the processing of a COBOL program. Now the question is that you have created your program, you have compiled it. Now how to execute that program on mainframe? So for that, you need a JCL. The term JCL stands for Job Control Language, and it is a command language of the ZOS operating system. And it is generally used to specify the program and the corresponding files or the output dataset where your output will be stored. And if you want to learn more about JCL, then you can check out our course on different platforms. Now coming back to the sample JCL, so first 2 lines is basically a job card, and after that we have specified the description about the job and the step. And if you look at the step 10, which is actually specifying the program that you want to execute with the help of this JCL, and thereafter we have specified the DD name that we have actually used in our COBOL program. So this is how you can use a JCL to execute or run your COBOL program on mainframe. Now let's move on to our next example, which is a COBOL CICS program, and this program is also reading data from a file. So the program is again divided into 4 different divisions, that is identification division, environment division, data division, and procedure division. The first thing you should notice is that the environment division does not include any entries and the data division does not include a file section. That is because the file that we are using in our COBOL CICS program is defined in the CICS file control table, that is FCT, because the file control table keep a track of the characteristics of the file and you do not have to code the select or FD statements in your COBOL program. But in case if you're using the sort statement in your COBOL CICS program, then you're required to specify the file details in the environment division and in the data division. The next 2 important section is working storage section and linkage section. And these sections are actually used to define variables which will be used internally within the program. To use the communication area, you need to provide 2 definitions for it in your program. One is in the working storage section and the other one in the linkage section. The working storage definition in this program is named as communication area, and the linkage section definition is named as DFHCOM area. Although you can use any name for the working storage field, but you must use DFHCOM area for the linkage section field. Now, if you notice the procedure division, which is generally used to specify your business logic, we have not used the native COBOL read statement, write statement, open or close statement, because if you are writing a COBOL CICS program, then you have to deal with CICS command. You have to issue CICS command from your COBOL program to perform various operations that you want to perform in your COBOL CICS program. you must use CICS command for most of the input and output processing. Therefore, do not describe file or code any open, close, read, rewrite, write or delete statement. Instead, use CICS command to retrieve, update, insert and delete data. So in this example, we have a paragraph that is A000-core-processing. Thereafter, we have a perform statement to execute a paragraph that is 1400-send-customer map. And after that, we have a small snippet of CICS command, which is actually reading data from the file. And if you notice, we have exec CICS and end CICS, and within that, we have issued the read statement to read data from the file. Now, if you want to run your COBOL CICS program, then you cannot do it directly with the help of a JCL. Because under CICS environment, a user cannot directly invoke a program. Instead, the user invoke a transaction, which in turn specify the application program to be executed. When a user invoke a transaction, CICS locate the application program associated with that particular transaction. Every transaction must be defined in a special CICS table, that is Program Control Table or PCT. It actually includes a list of valid transaction identifier, and each identifier is paired with a CICS program that will be loaded and executed when a transaction is invoked by the user. Another important CICS table is called Process Program Table or PPT, and it contains a list of valid program names. This table keeps track of which programs are located in storage. And the last table is FCT, that is File Control Table, and it is used to keep a track of files which is available to your application program. Apart from that, you also have a couple of additional tables which is used to define various resources as per your requirement. So these tables that we have discussed till now in this particular example is just for explanation purpose, how exactly COBOL CICS program is designed and how you can execute your program in CICS environment. Now let's move on to our next example, that is a COBOL DB2 program, and in this case we are actually reading data from a DB2 table instead of a file. So again we have four different divisions, that is identification division, environment division, data division and procedure division. So if you notice, in environment division and data division, we have not specified any file related details because we are actually reading data from our DB2 table. In case if you want to write any data to the output file, then you have to specify the file related details in the environment division and in the data division. Then we have working storage section where we have specified the working storage variables that will be used internally within the program. And thereafter we have a procedure division where we have specified our business logic. And again, we have not used any open statement, close statement because we are not dealing with file. We are actually using the DB2 database. And to perform any data related operation, for example, reading, writing, updating or deleting data from the table, then you have to use the SQL statements. And these SQL statements must be used within the exec SQL and end SQL notations. So you cannot use COBOL native read statements to read data from the table. Now, if you want to execute a COBOL DB2 batch program, then you have to use a JCL. So in this case, our program is a batch program, so we are using a JCL. So in case if you want to execute your COBOL CICS and DB2 program, that is an online program. So in that case, you have to specify all these entries in the corresponding table that we have discussed in our previous example. And then you have to initiate a transaction that will in turn execute your program. Now coming back to our sample JCL, that is JCL EMP03, we have a job card, then we have description, and after that we have step 10, which is actually executing a utility that is IKJEFT01, and it is generally used to execute a COBOL DB2 program. And if you look at the sysn, you notice that we have specified the program name followed by the plan and the library. So this is how you can execute your COBOL DB2 batch programs. Now let's talk about our last example, that is COBOL IMS program, and let's try to understand how you can specify the different file entries in your COBOL IMS program. So in this case, again, we have four different divisions, that is identification division, environment division, data division, and the last one is procedure division. And we are not required to specify any file related details in environment division and data division, because here in this particular program we are actually dealing with IMS database, and it is a hierarchical database. DLI act as an interface between an application program and the access method. To perform an operation on a DLI database, a program does not issue a standard COBOL file input-output statements, for example read, write, open or close, but it executes a call statement to invoke DLI. The parameters passed by the call statement tell DLI what operations are to be performed. Then DLI invoke the access method. So in the working storage section, we have defined the DLI functions. Apart from that, we have also defined the segment input output area. Apart from that, you normally define the working storage variables that will be used internally within the program. Then we have linkage section where we have defined the PCBs which will be used in the program. The linkage section definition of a PCB is called a PCB mask. Now coming back to the procedure division, we have actually used the procedure division with a using clause. And the using clause lists the name of the PCB mask that you have defined in the linkage section. Now in the paragraph A000-core-processing, we have actually used the call statement to request DLI services. The parameters you code on the call statement specify the operation you want DLI to perform. In the following call statement, I've actually used a function variable that is DLI-gn, and this particular variable actually denote a function that is getNext, and you can use it to retrieve segment occurrence in a sequence. It is like a standard COBOL read statement. Now to execute your COBOL IMS batch program, you need a JSL. And remember, you cannot directly invoke a COBOL IMS program with the help of a JSL because you need an IMS interface. That means your program is invoked under the control of DLI batch initialization module. Then DLI first load the appropriate control block and modules, then load your application program, and finally it'll transfer control to your application program. Now if you notice our JCL, we have used a specific program or utility that is DFSRRC00. Now there are four different parameters that we have specified with the PALM option. So the first one is program type, and in that I've specified DLI. Then we have program name where I've specified the program name. After that we have PSP name where I've specified the PSP name. And last you have the checkpoint ID. In case if you have a restarting process, then probably you can specify the checkpoint ID. So in our case, I've not specified any checkpoint ID. So this is how you can design your COBOL program to interact with a file or a database depending on your business requirement. So far, if you like this course and if you want to expand your knowledge around COBOL file handling capabilities and their implementations in COBOL programs, then I would highly recommend that you should check out our advanced version of this course on Udemy and Tutorial Point. In this course, we have actually showcased how to use the read statement, write statement, rewrite statement, and delete statement. Apart from that, we have also showcased how to use the start statement, how you can use the VSAM files in your COBOL program. So far, if you have any question, then do mention in the comment section. Otherwise, let's move on to our next topic, that is COBOL Web Services Interface. So first of all, let's talk about what are web services. So web services are a collection of open source protocols and standards used to exchange data between two different systems or applications. That means with the help of web services, two applications can communicate with each other over the internet. A web service has an interface which hides the implementation details. Apart from that, they use standard protocols to exchange data and functionality. Now there are two types of web services. First one is SOAP, that is Simple Object Access Protocol, and the second one is REST, that is Representational State Transfer. And as you know that COBOL is one of the oldest programming language that is still in use. But interestingly, it can provide and request web services using the architecture based on SOAP, that is Simple Object Access Protocol, or REST, that is Representational State Transfer. Apart from that, the format commonly used for displaying data in the interface of these services are either JSON, that is JavaScript Object Notation, or XML, that is Extensible Markup Language. Now let's try to understand with the help of an example. So we have a web application which is hosted on non-mainframe platform, and we have a COBOL application which is hosted on mainframe. Now, if you look at the example, you will clearly understand that a user has initiated a request from the web application to get data from the mainframe. Mainframe received the request, and the application which is hosted on IBM mainframe has processed that request, generate the output in the desired format, and again send the response back to the web application. And the data which is shared with the web application would be either in JSON format or in XML format. So far you're able to understand what are web services and how two different applications which is hosted on different platforms are used to interact with each other with the help of web services. And what is the importance of JSON and XML formats which is used for communication or sharing data between two different applications. Now let's try to understand what are the different statements which is provided by COBOL, and these statements can be used to generate either a JSON file or XML file. Apart from that, you can also consume JSON or XML messages or document in your COBOL program. Now if you look at the diagram, you can clearly understand that on one side you have web application which is hosted on non-mainframe platform, and on the other side you have COBOL application which is hosted on IBM mainframe. Now first of all, let's say our web application is communicating with COBOL application in a JSON format. So in this case, you can use two separate COBOL statements. The first one is JSON parse statement, and this statement is used to consume the JSON message that you've received from the web application. Apart from that, you can use JSON generate statement that will convert the COBOL data item or the COBOL output into a JSON format that can be processed by a web application. And similarly, in case if your web application is using XML instead of JSON, then you can use XML parse statement to process the XML text or the XML document that you have received from the web application. And you can also use XML generate statement to generate the data items or the output of the COBOL program into an XML format that can be used by a web application. So far, if you like this course and if you want to expand your knowledge around COBOL Web Services interface and their implementation in your COBOL programs, then I would highly recommend that you should check out the advanced version of this course on Udemy and Tutorial Point. We have given the link in the description. Now let's try to understand how to compile a COBOL program. So first and foremost question is that what is a compiler? So in layman term, a compiler is a program that converts the high-level program into low-level machine language that can be executed by a computer. So the important point is that computers can only understand or process low-level machine language. Now the entire compilation process is divided into four different stages. So the first stage is syntax scanning, second stage is semantic analysis, third stage is code optimization, and the last stage is code generation. So if you want to execute a COBOL program on mainframe or non-mainframe platform, then it has to be compiled with the help of a proper COBOL compiler. And remember, we do have different categories of compiler, and these compilers are very specific to the computing platform. So in case if you want to execute your program on mainframe platform, then probably you'll pick up a compiler that is available on mainframe platform. And the latest version that is generally being used on mainframe platform is Enterprise COBOL for ZOS, that is version 6 release 3, and this is provided by IBM. Apart from that, in case if you are working on a non-mainframe platform, then probably you'll go with a Micro Focus COBOL compiler or any other compiler which is available in your project. So finally, the input to a compiler is a high-level program code or source code, and the output would be the object code or machine code. Now let's talk about various steps which is involved in compiling a standalone COBOL program. And when I say standalone, that means that I'm not talking about any COBOL DB2 program or any COBOL CICS program or COBOL IMS program. This is a simple COBOL program that has no additional functionality of CICS, DB2 or IMS. And remember, you're not required to follow these steps manually because in most of the cases you have version control tools that do most of the heavy lifting. And in case if your project is not using version control tools such as Endeavor or Changement, then your project will have a standard compilation JCL that will do the same task that the version control tool is actually doing. Now coming back to our compilation process. So the entire compilation process is divided into two different phases. The first phase is compile, and in this phase, compiler read the source code. That means it will go through the program, it will validate the syntax that you have used in your COBOL program, and in case if you have used any copybook, it will expand those copybooks in your COBOL program. And finally, if there is no syntax error or compilation issue, then compiler will generate the object code. The object code is used in our second step, that is link edit step. In this step, the object code is linked with a subprogram in case if you're using any subprogram in your COBOL program. Please note that subprogram should be compiled separately before compiling your main program. And the output of linkage editor is a load module that can be executed or run via JCL. So far, if you have any question, then do mention in the comment section. We're going to respond back as soon as possible. Otherwise, let's move on to our next topic, that is how to design a COBOL program and what are the important points that you should always keep in mind when you're designing your COBOL program. So as you know that COBOL is one of the oldest programming language and it is widely used in enterprise computing. And in most of the cases, COBOL applications are hosted on IBM mainframe. And when you talk about IBM mainframe, then cost is one of the important factor that cannot be ignored when you're writing your COBOL program that will be deployed on IBM mainframe. So here are the following steps that you should follow when you're writing your COBOL program. So the first and foremost step is define the problem. So before writing any COBOL program, it is important that you first of all understand the problem that you want to address with the help of this particular COBOL program. Apart from that, it will help you in understanding what are the input, what are the output, what are the processes, and what are the functions that you're going to use in your COBOL program to achieve the requirement. Now the second important step is determining the inputs and output. So based on the problem that you have defined in the previous step, you need to determine what are the input and output to your program. So for example, if you want to generate a report of unsuccessful transactions, then probably you need an input file that have a list of all transaction records, and that particular file would be feed into your COBOL program, and based on the business logic, it will generate the report. So the input to this particular program is an input transaction file and the output would be a unsuccessful transaction report. Now the next important step is design the data structure. So once we have determined the inputs and output of our program, we can start designing the data structure that will be used to store the data. In COBOL, the data structure can be represented using a variable, array, or records. And we need to choose the appropriate data structure based on the type of data we are working with and how it need to be processed and stored. The next step is to write the program specifications, which include the steps the program will take to solve the problem. And the program specification should include the input and output of the program, the data structure used, the step taken to process the data, the formulas and calculations that will be used in COBOL program to achieve your requirements, the condition that must be met for the program to run correctly. Now it's time for us to write the COBOL program because we have the clear understanding of the program requirements. So the entire COBOL program is divided into four divisions. First one is identification division, then we have environment division, then we have data division, and after that we have procedure division. The next important step is compiling and testing the program. So after you have written the code, you will need to test it thoroughly to ensure that it meets the business requirement and there are no bugs or error in the code. Now the final step is deploying the program. So once you're satisfied with the results and the performance of the program, you must deploy the program into the production environment. However, you might need to make some final adjustments to ensure that the program runs smoothly in the production environment. So these are the general steps which is involved in designing a COBOL program. The specific design you will need to follow will depend on the business requirement, the complexity of the program, and the specific COBOL implementation that you are using in your project. So far, we have discussed the fundamental aspect of COBOL programming. If you are looking to enhance your understanding of advanced topics such as COBOL file handling capabilities that include read, write, or delete data from a sequential file or from a VSAM file. Apart from that, we also discuss how to use JSON generate statement or XML generate statement to generate the XML or JSON messages from your COBOL program. And on the other hand, how you can process these messages in your COBOL program. We've also discussed the arithmetic operations in detail and how you can use them in your COBOL program. Apart from that, we have also showcased how to use the COBOL compilation process that include COBOL CICS compilation process and COBOL DB2 compilation process. On top of that, we have also included mock interviews and quizzes. Apart from that, you can also try our JCL complete reference course, and with the help of this course, you can learn how to write and execute JCL on the IBM mainframe. Apart from that, you can also use these JCLs to execute your COBOL program. And in our COBOL complete reference course, we have provided the COBOL programs and sample JCLs so that you can execute them on the mainframe environment. Last but not the least, if you like this video, then hit the like button and share your feedback in the comments section. And do share it with your friends, and please consider subscribing to our channel because your subscription is very important for us. Thank you so much for watching the video.